part 3 of lesson 4.1, which is about solving systems of equations. We've already discussed using graphing as a method, but unless it hits a grid point, it's hard to tell exactly where it's at. We've been doing substitution. We said it works out well when one of them is already solved for x or y, or is easily solved for x or y. But I think you're going to see in the next two that substitution is not always the simplest method, especially when there's fractions involved. So at this point I'll quit talking and go ahead and I'm going to write these side by side just so I have room to work on each one separately. It doesn't really matter if you write them vertically or horizontally, but I'm doing this so I have room below to solve for x or y or whatever I want to solve for. Okay, looking at it, I felt this one was probably the easiest one to solve for x, because it has x by itself already, or x has a coefficient of 1. I guess that's what I should say. The 2/5 y needs to be gotten rid of, so I'm going to minus 2/5 y on both sides. I could have gotten rid of the fractions to begin with, and maybe I should have, but well, we'll see. X is equal to negative 2/5 y minus 8/5. Okay, right there is what x is. And I don't think there's going to be a simpler way to have that written. So even if I had gotten rid of the fractions, when I divided by whatever was in front of the x, I'd end up having fractions anyway. So now we're going to take this right here and we're going to substitute it over here for x. So I have 2/5 times x, which is this right here, and now I no longer have x's in my equation, I just have y's. So I'll solve for y. First thing is to get rid of parentheses. 2/5 times negative 2/5 is negative 4/25. And 2/5 times negative 8/5 would be negative 16/25. Okay, at this point I do have a lot of fractions, and so I probably should go ahead and get rid of them to solve for y. So I'm going to multiply everything by 25. (25) divided into 25 is 1. 1 times negative 4y is negative 4y. 25 divided into 25 is 1. Negative 1 times 16 is negative 16. 5 goes into 25, 5. 5 times 1y is 5y. The fractions are took care of. I'm going to combine my like terms right here. The negative 16 is on the wrong side. So on the left, I'm going to go ahead and combine these. Negative 4y plus 5y is 1y. And on this side, I've got negative 25 plus 16 is negative 9. And I know what y is. Now that I know what y is, I can come back over here, plug it into my equation. And this doesn't look like it's going to be very pretty. Negative 2 times negative 9 is positive 18 fifths. Take away 8/5. Now these do have a common denominator already, so I'm just going to go ahead and subtract them. That would be 10/5, and 10/5 is 2. So I know what x is, I know what y is. The ordered pair that's the solution is 2, -9. Notice it was a lot more work because of the fractions. When there's fractions, this may not be your best method to solve. Okay, now we're going to try number 22. I think if I minus 2/3 on both sides, or 2/3, x over 3. I get negative x over 3 plus 2 divided by -1. Negative divided by negative is positive, and positive divided by negative is negative. There's my expression for y. So I'll substitute this for y into the other equation. And I believe before I do that, I'm going to get rid of the fractions in the equation, because if I don't, substituting this into this mess will be very messy. I'll multiply this by 8, which is the common denominator over here. One times x is x. 4 times y would be negative 4y equals 8. Now I'll substitute. After I get rid of my parentheses, I'll probably go ahead and get rid of the fractions again. 4 times 1/3 is 4/3. X, negative 4 times negative 2 is plus 8. 4/3. Now, let's just get rid of the fractions. Go times everything by 3. (3x minus 4x is negative 1x) plus 24 equals 24. I'm going to minus 24 on both sides. And I still have an x that's negative 1x. That equals 0 though. So when I divide by -1, I still have x equals 0. Now if x is 0, I'll plug it back in right up here. One-third times 0 is 0. Take away 2 is -2. Okay, that wraps it up for doing substitution. The last method that we learned is elimination, and that will be covered in the next video.